So this is normal line to a curve. And so what a normal line is the line that's perpendicular to the tangent line at the point of tangency. So if we have our function, you get a point here and you have a tangent, the normal is the one that is perpendicular to it. So that would be the normal line. And if you remember with slopes, if this slope is a half, the slope of the perpendicular would be the negative reciprocal. So you just take that slope, flip and change the sign, and now you have the normal. Well, the slope of the normal. So we have the slope of the tangent, slope of the normal. All right, so what we're going to do is find the equations of the tangent line and the normal line, and there's not much of a difference in what we're going to be doing. So first we find the slope of our tangent line to create an equation. We then can take the slope of our tangent, do the negative reciprocal, and we get the slope of the normal line. They both share the same point. You can see they're both going through the same point, so it could be a very quick equation. All right, so let's first find the slope of the tangent. So the slope of our tangent is our derivative. That is our slope of our tangent. So we need to take our numerator, which is x, and our denominator, which is 1 plus x squared, and we're going to be using quotient rule. So f prime would be 1, and g prime is 2x, and then we do our little multiply. So 1 times 1 plus x squared minus, and then 2x times x, all over the denominator squared, just like that. So we double check this. Derivative of x is 1, and then we get 1 plus x squared. Derivative of the denominator is 2x, and then we multiply it by x. There's a minus in the middle, and 1 plus x squared squared. All right, now we simplify. So this is 1 plus x squared minus 2x squared over 1 plus x squared squared. This is 1 minus x squared over 1 plus x squared squared. All right, and so there we have it. So now our point is 1 comma 1/2. So if we plugged in 1, we'd get 1 over 1 plus 1 is 2, so it's 1 over a half. So 1 comma 1/2. Now to find the slope at that point, we just need to plug it in. So again, we have our curve. Our point is 1 comma 1/2, and we have a tangent there. And by plugging it in, y prime of 1, it's going to give us the slope of the tangent. So now we take this, we plug in our 1. I'm just plugging in the x coordinate. That's it right here. That's our x. X is equal to 1. And we end up with 1 minus 1, which is 0, over 1 plus 1, which is 2. And so it's 0. The slope is 0. Forgot the squared, so it'd be 4, but it's still 0. And so now we can find the equation of our line. So we need to find the equation. So if we take that slope equals 0 and our point 1 comma 1/2, then if anytime you have a slope of 0, that's a y equals equation, and our y coordinate is a half. So this would be the equation of a tangent at 1 comma a half. So now the normal line is just the one that's perpendicular to it. And so all we have to do now is think of 0. So if it's 0, the perpendicular would be undefined. And so this is the x equals, and so that would be 1. And so this is the equation of the normal at 1 comma 1/2. And so here's our function, and you can see it's going in here. That's our function here. And so I've already plugged in x equals 1. That was our point 1 comma 1/2 right there. So you can see that's our point. 1 comma and a half. And so if I go to 1, back to 1 right there, you can see our slope is 0, and there's our equation, y equals a half in green as I mark it. And then the normal would be the one that's perpendicular to it. So right there, that's x equals 1. It's vertical. And so you can see these two are perpendicular to each other. So the blue is the normal, and the red green now, is our tangent. Okay, so let's try this again, but this time with a different point. So same exact equation, but we're going to pick a different one. Since we already have a formula that tells us the slope of the tangent, we can pick any point we want. So if we go back to our graph, let's look at it. 0 looks like a good one, right? So if I were to take a back to 0, right there, you can see that is our tangent, and so then the normal would go this direction here. So let's try it at 0, because that's a nice point to plug in. So we're going to take our same equation. We know that y equals x, 1 plus x squared, and we already took the derivative of that function, and we got 1 minus x squared, 1 plus x squared squared. And so now if we plug in 0 into that function, you would get y equals 0 over 1 plus 0 squared, which is 0 over 1, which is 0. So we now have our point. So that was our graph here. Our point is 0, 0. And so now we're going to find our tangent going through it. So just like that. That was our tangent. All right. So if we plug that 0 in, you can see we get 1 over 1 squared, which is 1. And so that is the slope of that line. That is the slope of our tangent. So if we make our equation, we take the 0, 0, and the m equals 1, and we plug it in, it's y minus 0 equals 1, x minus 0. We get our equation, y equals x. And so if we go back, plug it in, you can see there's our y equals x. By the way, this little blue dot is the derivative itself, which we're just not looking at. So that's y equals x. It checks out perfectly. And so now we're going to do, this is our equation of tangent. So now we're going to do the equation of the normal. So again, it shares the same point, 0, 0. We just now need that line that is perpendicular. So they both still have the same one, but we need to negative reciprocal it. So it's just negative 1. So if we take our slope of 1 and flip it, we get 1. And so it becomes negative 1. This is for our normal. And now we do the same exact thing. Y minus 0, negative 1, x minus 0. So we get y equals negative x. And so there is our tangent, and there is our normal. And so you can pick any point you want on the function, and you can see that you're going to get a normal line and a tangent. They're always perpendicular. So whatever you get for the slope of your tangent, just negative reciprocal it, use the same exact point, and it'll give you the equation for the normal line. Thank you.